button. Osha, I love your icon, and this is not me asking you to put your video on. I'm not like other teachers that make you put your video on. It's fine. I understand that it's early for a lot of you, and you know, if you want to be in bed or whatever, that's fine. I just think Osha's is funny because whenever I say something funny, I look down at Osha's icon and it looks like she's laughing. So I'm like, ah, okay, great. I'm entertaining people. Oh, it's just a photo.
I love that.
Okay, we have a lot to go over today. Can I help you find something? Okay. Ah, you took it. Okay, stop. Sorry, my friend is distracting me. Okay, I clicked record, right? All right. So we have a lot to go over. I watched my recordings from the last time I gave this lecture and I was like, I went way too slow. This was broken up into 2 lectures. We might have to do that again. I hope not. I don't have time to fit in 2 lectures. So I'm really going to kind of race through a lot of these things. Luckily, we have open office hours after. So if you have any kind of deep questions, we can kind of go over that. And it might bleed into open office hours like yesterday. So, you know, these are important. So please, please, please ask questions about the stuff. There are some things about JavaScript, like we mentioned yesterday, that I'm still discovering. So we might have to kind of, you know, just practice doing these things live. But let's just get into it. So things we're going to talk about today: setting variables, var, let, and const. What is the difference? When to use what? We'll dive further in today about why not to use var. Let and const are part of the newest versions of JavaScript, and they just do so much stuff for us. Const is really, you can find a bajillion articles on why to never use var. However, you will still see it. It's still something that you can do. So we'll just, you know, go over that more. And then fundamentals. So what are the data types in JavaScript? Strings, numbers, booleans, arrays, objects, undefined, and null are all of, when I ask you something, I may have asked you before, I ask, what is the data type? Is it a string? Is it a number? Is it a boolean? Is it an array? Is it an object? Is it undefined or is it null? These are all JavaScript data types, okay? We'll review what pass by value versus pass by reference is. This applies to arrays and objects. I need to look this up again. Using type of to figure out data type. I believe it's just a method that we can call. It exists in the window. We'll talk briefly about comparison operators and coercion. You will start seeing the triple equals sign in Rails, in JavaScript, which I don't think is something that we saw in Ruby. I don't think. Yeah, comparison and coercion. And then we're going to talk about functions. I'm going to do a broad kind of overview of functions, but we're going to talk about specific way of writing functions that I want everyone to focus on. There are 2 ways to write functions, arguably 3 ways to write functions. Well, 2 principal ways to write functions, and then they kind of have their own, you know, modifications. But I'm gonna really force you all to try to write it one way, although you're gonna see it both ways in the lessons. And then we're gonna talk about some weird JavaScript idiosyncrasies that are definitely different than Ruby: scope, closures, and hoisting, okay? So today we're really gonna kind of lay bare, you'll be able to see the similarities and differences between JavaScript and Ruby. And remember, I've said this before, the big difference between JavaScript and Ruby, or the hardest thing about transitioning, is that they're so close, they're very similar, but they can behave in ways that you're not used to them behaving. So it's just about parsing out which bits of code familiarity to carry over from Ruby and which bits you have to recognize as being different. And I mess up all the time. You know, you're going to see me try to write something in Ruby when it should be when it's different. It's okay. You know, give yourself permission to have those kind of slip ups through the rest of the program. So do not, you know, this isn't something that it's going to change automatically for you overnight. Okay. Just practice, just like last time. Okay. Are there any questions before I start? Jeez Louise. Okay. Come on. Okay. All right. So I kind of have this JavaScript file laid out. All these bits of code are commented out, and we're just going to kind of follow through them as we need to. Again, I'm going to kind of go through this really quickly, but please don't hesitate to stop me if you need to clarify anything. Or, you know, if it sounds like a longer question, write it down and we'll get to it at the end when we dive into office hours, okay? So variables in Ruby or JavaScript. Wait, I'm sorry, I didn't pause for questions. Any questions? No? Okay. So var and let are two ways to let you define variables, allow you to declare a variable without assigning it a value. Okay, so that means that I can say var student and let student2. Okay, look how I define them, or I declare them, but I don't assign them a value. Okay, var student, let student. Right now, these values are undefined because I never defined them. We'll talk about this more when we get to data types. Undefined simply means, hey, this value exists. You never gave it a definition. Okay. Const does not let you do this. If I try to say const is something, and we're going to just use the console here as a, let's see. So I actually have this file open. I just prefer to use this actually. Oh, I don't know if I'll get to this today. I don't know why I have this. That'll probably be for tomorrow. And don't worry about this error. That has to do with something else. So it's fine. If I try to say, so I can say var student, I can say let student2, right? I don't have to define them, right? But if I say const student3, it's going to say, hey, you need to initialize this, meaning you need to assign it a variable, okay? I can come back later and define student2 as Osha, you know, and student1 as Micah, for example, right? So I can define them without giving them a value, right? They're undefined. And then kind of what I just said here, student3 needs to be defined. So we'll say that student3 is Regina. Okay. Basically, never use var. It gives you too much freedom. Here are kind of the three main reasons why. It never throws an error if you declare the same variable twice. Big problem, right? For let and student, if you try to define them again, you'll get an error saying these have already been defined. var doesn't give you that error. You can also redefine var at any moment, just kind of like let. Yeah, so if you try to define a var twice, so let's see this here. So if I say var student, it's not going to give me an error, but if I say let student2, it's, oh, that also works. Sometimes there are also things that happen in the browser console that don't happen if we, so let me try to do this. Let student2. Shoot. Okay. Well, another thing that I wrote down that apparently isn't true. If I try to say const student, and then I say const student equals Osha, and I say const student again. So it's gonna, oh, that's also working. Const student equals Osha, not Osha. What? Oh, that's because I spelled it wrong. Student. Yeah, identifier student has already been declared. Huh. I thought that let was block scoped so that you couldn't define it twice. So if I say let student2 equal another student, and I say let student2 is yet another, yeah, wow, crazy. Okay, so we'll say that it never, yeah, well, that's also true for, which is also true for let apparently. Let me Google this really quick.
Chris, I believe in the lectures it said that you just use let when you want the variable to change throughout your program, whereas const should be pretty much the default as best practice.
Yeah, that's right. But let lets me define variable twice, JavaScript. And let and const, you cannot declare the variable twice, right? But we just did that. How to prevent a let double declaration. Okay. So in some cases it seems to be working. Maybe it's because I didn't define it first. So no, I did do that. That's student 3. Yeah, it's so strange. This is from a year ago, so I don't understand. If I open up JS console and write foo, and after this it says foo has already been declared. Why am I not getting that error? Let me take this out. I don't know where this is coming from. I'm just gonna take all of this out. Yeah, crazy. Okay, so then which one gets defined? Student 2. Student 2 is not defined. Oh, okay, that's why. I just realized that I was not requiring this here correctly. I think I used this. Okay, so now I'm getting this error. Student 2 has already been declared. So somehow it's tricky to use the console. Sometimes the behavior in the console is different than when the browser is reading a JavaScript file. So when I ran this JavaScript file in the browser like this, it won't let me declare this variable twice. So I was right. Okay, so my bad. I'll have to try to do things. I'll just reload the JS file.
So you can you can't declare it twice, but you can change it.
You can change it. Yes.
A let. Okay,
Right,
I thought we were talking about changing, not declaring.
So whenever you write let, you're declaring a variable, right? But I can go down here and I can reassign the variable, right?
But that's what it's called, assigning.
Here.
Okay, yeah.
Yes.
So you can reassign.
This is assigning. Exactly.
Okay, cool.
Right. Exactly. Okay. So the idea here is that if I do var and say student again, the error that I shouldn't get an error because var doesn't throw an error when you try to declare a variable twice, which is one reason why we don't want to use it, right? Okay. So with let is like var in that we can declare them but not give them any values, right? Let does not let us declare the same variable twice, so we can't do this. Declaring a second time would throw an error, but we can change. Okay, we could do the same thing for var as well. David, great. Const is generally for something that you're assigning it to a variable and you never want it to be, redefined again. So let's finish this. Var never throws an error if you declare the same variable twice. They're only function scope, not block scope. I'll talk about that in a second. Linters and most JavaScript pros say it's bad practice, just don't use it. Okay, but it's important to know about it a little bit. Let me toggle soft drive really quickly. Can everyone kind of read this? I know it's like on black. It's on gray, dark mode, my comments, but if you want me to go off dark mode, I can.
So it's fine.
Okay, sounds good.
Thanks.
Okay. Let allows you to change the value of a declared variable and does not let you reassign the variable name later, which is what we just looked at, right? We can change the value of the variable, but we can't declare it twice. Let is best for iterators where the value of something has to change. We'll see if we can take a look at this later, but if not, this is definitely something that we're going to see. Const does not allow you to declare a variable without passing a value, and you can never change the value, right? So if I say const student3 is Franklin, then I can never change the value of student3. Okay. You are encouraged to use const as often as possible, although some big JavaScript developers say const was a mistake. And then I have this link to this really funny Twitter thread where people are just arguing that const should never have been invented. But Dan Abramov, one of the guys who runs React, kind of has a rebuttal. But it just kind of goes to show that people will argue about anything on the internet. So when you ask me if something is best done this way or the other, you know, you're going to find arguments for and against. Okay, so any questions about declaring variables? Okay, data types, strings, we're working with them already up here, right? You know, let dog equal Sadie, right? We can say, let's say hi equals, you know, say hi, or we can say name, or maybe this is just a person. We can say my name is, right? And then we can concatenate them, person plus, or say name plus person. Would return my name is Sadie, right? We can, let's see if this works, if it comes out in the console. Oh yeah, I need to write console log. So whenever you want something to show up in the console, this is kind of like puts. Let's see if this works. My name is Sadie, okay? Console log is the primary debugger of JavaScript. Whenever you want something to appear in the console in your application, you need to wrap it in a console log, okay? It doesn't work like return, right? Or, you know, and it's the same thing in Ruby, right? If we want to put something in the console, we use put or print, right? But everything also has a return value, right? So nothing in here has a return value. We're not calling a method or a function or anything. So if we want to see something in the console, we need to use console.log. We're going to use this all of the time, all of the time. You're going to have a bajillion console logs in your application. Console logs you can just put, you can say, you know, we are inside this function. It kind of, console log just kind of, it helps us see the order in which our application is kind of unfolding, but it's also great for just, you know, writing messages as reminders in the console for us. So I'm going to use console log right now to kind of use examples of how we concatenate strings, okay? We can also use interpolation here. We can say interpolation. If we want to use interpolation in JavaScript, we need to use the backticks. Backticks are, if you're on an American keyboard, it's next to the one. It's right before the one underneath the escape generally, right? So it's different than these and these. It's this, okay? So we can say my name is, and then we can interpolate. The interpolation uses the $sign instead of the pound sign. This returns the same value, okay? Any questions about strings? Cool, they work basically the same as you would in Ruby. You can take pretty big guesses with them and how they work. Numbers, let 1 equal 1. Let 1.5 equal 1.5. Numbers can be whole numbers or decimals, okay? We can multiply them. oops. Okay, 2 times 1.5 is 3, right? We can divide, add, subtract, right? Just basic arithmetic. Basically the same. There are some kind of weird, the decimals behave strangely at some point. I think if we did like 22 times 1.5, we might get like a weird, no, that's not bad, okay. There's a lab in the future where try to increment things by like 0.05 and we start to get some weird numbers, and we'll cross that bridge when we get there, but arithmetic numbers work basically like they do in Ruby as well, okay? We'll talk about coercion here really quickly. If we see that there is, if JavaScript sees that there is a number and it's being added with a string, it is going to return 55. What it does is it looks at both of these, and the order doesn't matter here. It says which of them is easier to turn into the version of the other, right? A string is pretty hard to turn into a number, right? I can use this parse int value here to take a string and turn it into a number, right? But if I'm adding 2 different ones together without using this parse int, 2 different data types, it's going to say, well, 5 is kind of hard to turn into a number, but it's much easier to just put 5 inside of a string and just make this a string, right? So when faced between an integer and a string, and trying to combine them together, JavaScript is going to take the integer and it's going to turn it into a string, okay? So if I had 55 plus 5, it's going to be 555, all right? So keep that in mind. We can't really do it the reverse. I forget if parse string is a, no, parse string. Nah, I don't remember. There might be a way to turn a number into a string. I just can't remember it off the top of my head. I just kind of wanted to give you one example of coercion. So if you see yourself trying to do this in JavaScript, you might there might be some problems here if you're not accounting for this, right? So again, use your console log to ask yourself, is this number what I think it is? And again, remember in questions to kind of unmute yourself and ask me, because the icon is really small and I might miss your questions along the way. So to kind of review, linters, OSHA, linters are kind of tools built into text editors that help you catch errors without having to run your code. I don't use them, but in a dev setting, you probably will use them, or you might be on a team that all uses the same linter. It's just saying things like, hey, you forgot something here. This is going to throw you an error. It's just kind of like live kind of in your text editor errors.
Thanks.
Yeah, you got it. It's to increase code quality for, I don't know what that means, Franklin. When you declare a variable, do you have to say, I do declare? It has to start with Blair St. Clair, I do declare. Otherwise, it just won't work. Okay, fine. Maybe it's better that I just don't look at the chat so you guys can just kind of, if you have a serious question, I appreciate the chat. I appreciate you guys talking to each other. But if you have a serious question, unmute yourself. It says my screen sharing is paused. Resume share. Okay. Okay, so that's kind of just one example of coercion. We'll kind of see this again. How do we create a new variable with the difference of 2 values? These are just some exercises that I did previously that I don't think that we have time to do now. Okay, and then a quick thing to kind of remember is the increment operator and the decrement operator. Well, let's talk about these really quickly. So we can define a variable like let I equals 1, right? If we're working in a loop, we'll do it this way. If you haven't seen loops yet, it's okay. I don't know if we'll have time to get to one today, but you'll definitely see loops, right? And then if we want to increment something, we would say I++, and then the value of I is now 2. So to look at this here, we say let 2 equals 2. Oh, let 2 has already been declared. Okay, let number equal 2 or equal 3, and we could say number ++. right? It returns 3, but also the number 3 variable is now 4. Oh, interesting. Okay. So the return value is what it was before, but the variable has been changed to what happens after the incrementer has completed. Didn't know that. It also works in the inverse, or we'll say second num. Second num is 5. We can say second num minus minus, and that is, oh, what happened? Oh, I did spell it incorrectly the first time. So when you see this NaN, it stands for not a number. So what JavaScript said is you're trying to decrement a number, but it's not a number. NaN. That's what it means. So the return value again is 5, as we've seen, but if we go check the value of the variable again, it's actually 4. You'll see this happen, you know, in different methods, right? For, you know, if we pop something off the end of an array, the return value is the element that we removed from the array. It's not the new array with that element removed, right? So you'll see this kind of weird return value behavior with these operators. So an increment and decrement operator. Any questions about increment and decrement operators? Okay, Boolean values. Let logged in equal true. You can change logged in to false. Pretty simple. True and false, just like in Ruby, right? One thing to remember is that empty strings, 0 and undefined, empty strings, 0, undefined, and null are all considered false in Ruby. Everything else is true, or it would coerce to true, right? We could say 0 equals false is true. Empty string equals false. That's also true. Undefined is false. That's true. Oh, that's not true. Undefined is not equal to false. Okay, good to know. We'll take that out. Null equals false. That's also false. Okay. I think that these can maybe be coerced to false, right? Because we can ask basically the question, we can say null and undefined can be coerced to false. And what I mean by that is if we were doing an if or operator, right, we could say if, and if we pass in the value as null or undefined, it would be registered as false.
It would be falsy.
What do you mean?
Well, like the where equal equals, it was not false, but triple equals it was false. That
no, it wasn't
falsy
false
at all.
Neither of them were falsy.
Undefined there. Oh, there it is.
Yeah, undefined is also false in both cases. So I guess what I mean to say here is that undefined and null are never going to pass when you're using an if statement to test if something is true or false, right? But 0 and an empty string both equate to false in Ruby. All of these examples would never pass an if-else statement, right? An empty string is 0. The word false, null, and undefined are never going to pass an if-else statement, but null and undefined don't necessarily equate to false. I could say equate to false. The difference between undefined and null. Undefined means that you've declared a variable, you just never assigned it anything, and null is a value that, and then null is it's a value that we assign, right? If you ever see null, that means we intentionally put it there, and it kind of just means reserve this space for something that hasn't quite been filled in yet, or that will fill in the future. Right. So if we have like a logged in user and no one's logged in, maybe the logged in user is null, right? And then when the logged in user does log in, we can say that they're an object. And we'll get to this in a second.
Would null then
null-
show if we're using, like, for example, a method with a required argument and we don't put in an argument?
A method with a required argument.
Like, or maybe instead of argument, I'm supposed to say variable. But I'm saying, like, if we
Yeah.
create a method and that method requires a variable, and we do not put a variable in when we invoke that method, is that going to return null?
That's a good question. I think it's going to return undefined. But let's see if we can look at this down at the bottom. I'll put a note down here.
Sure. Whenever.
What is the value of an argument inside of a function if when the function is executed, we never pass in the variable? Okay, good question. Okay, arrays and objects, basically the same thing, right? Let array equal something like this, right? Let object is this. Objects are what hashes are in Ruby. They are also made up of key value pairs. Unlike Ruby, where you can also write something like this, this syntax does not work in JavaScript, so do not write things this way. Key value pair, these can, let's see, yeah, they're generally written like this. I feel like you might be able to write them like this. Let's see, can I write this like this? I'm forgetting. Oh, right, value needs to be something. So key, and then I'll have value. Okay, so that does work. But look how it's kind of erased from the string. So with objects, we can use dot notation to access keys. We can also use bracket notation to access keys. But in bracket notation, the what we pass in has to be a string, like so. If you are working on an object and inside of a function you want to grab one of several keys, right? We can also do interpolation here if we use backticks to kind of achieve the key that we want. And that's kind of a trick that you might find yourself using later. But in order to access keys, again, you can use dot notation or you can use bracket notation. Basically, it feels like calling a method on that function or on that object, right? Or bracket notation. Which is maybe how we're more familiar with doing this in Ruby. So remember that arrays and objects can be passed by reference and not by value. This was the same situation in, let's see, my AirPod's gonna die. Please don't. Look at how strange this is. My left battery is at 61 and my right's at 10, but they both started off at 100. I don't know how to fix that. Just maybe time for new AirPods. So what this means is that arrays are passed by reference and not by value. What this means is that whenever we define an array or an object, they are given specific spaces in memory, right? And if we ever reference that array or object, right, we can have, essentially it means we can have two variables pointing to the same array. So if I say let array of nums equal 1, 2, 3, and down here I say let copy equal array of nums, right? Both copy and array of nums point to the same variable. So let's take a look at this. Copy, oh shoot, why is this not working? I define this variable here. I'm requiring index.js. I think it's because of this error. It didn't compile. Value is not defined. Which is here, and this would be this. So we have copy. Okay, so we have copy and we have array of nums, right? If I take array of nums and I push a value of 4 onto the array, I've added 4 to the end of the array, right? But if we go look at copy, copy has also changed. This is because arrays and objects are passed by reference, meaning that if I tell one variable, hey, you know, I guess this is a false term. This isn't a copy, right? This is a reference to the same place, right?
So it's just essentially a pointer to the same location in memory.
Right, exactly. The two variables are pointing to the same variable that's stored in the same place in memory, right? So if I ask the question, is copy the same as array of nums? The answer is going to be true. Yes, they are the exact same array, right? This causes problems, right?
This is where you want to make copies of any of your objects before you actually start doing operations on them.
Exactly. So I'm not going to call this copy. I'm going to call this same reference. So same reference, an array of nums, right, points to the same object in memory. But if you want to, this is going to become a huge concept that we'll talk about over time. But there might, when we're using arrays and objects to store important information about our application, we might want to exhibit a change. And usually when we make a change to preserve kind of history or to make sure that we're not referencing the same kind, you could argue that it's along the lines of kind of maintaining a single source of truth. I guess the easiest way to talk about it is the way that we're going to see it in the future, right? As our applications change, there's maybe going to be something called state that manages the state of our application. So there might be a user that's logged in, right? So if we have we'll have something called state, and we'll have like logged in, and that might be false, and maybe dark mode is on, right? Something like this, right? So if I go in and I change state.loggedin is true now, we've basically changed a version of state, right? The state is now, we've updated something. But there's a principle in JavaScript that whenever we make changes to state like this, we always want to make a new instance of our array or our object that's holding state, right? It's just it just signals a moment. It's like, it's better for us to like make a copy. JavaScript and React in particular will also kind of keep record of the way that your state has changed in the past, or the way that, you know, when we start talking about page changes, like a history of how the user has navigated through the page, right? And so those arrays are obviously going to look different. If we're maintaining a history of the way our application looked at a certain point in the past, then of course we don't want to be using the same array and the same object throughout the entirety of our application, because they themselves don't necessarily hold their history, right? So whenever we're making changes to something in particular that is indicating the behavior of how our application is running, for arrays and objects, we generally want to make a copy of it. And the way that we make copies, you'll see a bunch of different ways in the lessons, but the newest, most advanced way, using ES6 syntax is what we'll call it, is to use what's called the spread operator. And so if I want to make an actual copy, right, I would say, I'll make a new array and I'll put these 3 dots in front of it. And what the 3 dots do is it's saying, make a shallow copy, meaning that if I have nested values in here, those nested values, if I have nested arrays and nested objects in this array or in this object, those values are still going to point to the same place, right? So when I say a shallow copy, make that first level, make a copy of the values of the first layer, and break off, create new references for them, right? We don't want the references to be the same. So I'm going to now say array of nums here. And what we're going to have now is we're going to have copy and array of nums look the same, but they are no longer the same array. They point to different spaces in memory. Okay. So again, I know this concept is confusing. Super important to kind of dig your teeth into. So if you have more questions about this, let's talk about this during open office hours. But it works the same thing for objects, right? So we have an object with you know, a key and a value like this. Okay, so that already has been defined. I'll say new object, right? If I say let same reference of object equals new object, these new objects, these obviously are going to point to the same places in memory. Okay, but if I want to make a copy, I'll say let copy of object equal, and then we'll use the spread operator here to make a shallow copy of new object. And now a copy of the object has been created so that any changes to this, right? And just like kind of in Ruby, we can make a new key here, and I can set it equal to new value. And then I have a copy of an object that has a new key and a new value, but the original object has not been changed. Okay. So when we're saying pass by reference and not by value, by reference means the reference of, you know, the space in memory. But obviously, if I say, you know, let first number equal 1, and I say let second number equal first number, numbers and strings are passed by value. So first num and second num aren't pointing to the same space in memory. I've basically said they're the same value, but the variables themselves are in different places, right? So first num is now equal to 1, and second num is now equal to 1. But if I say second num plus plus and increment it using our increment operator, second num and first num have maintained separate values, because numbers and strings are passed by value, right? Or when I take a variable and I point to another variable, if that variable is a string, JavaScript isn't going to share that number's space in memory with me. It's just going to share the value of that number with me, right? And I'll say, oh, okay, you know, you're number 1. I'll just say I'm number 1 too. But when we're talking about arrays and objects, if I'm taking a variable and I'm pointing it to another variable, right, and that variable is an array, the variable is going to say, I'm going to give you the reference to this variable, or sorry, to this array or this object in memory. Tricky concept, but just remember it's specific to arrays and objects. And if you don't get this now, this is definitely something that we're going to come up against. And if it's not clicking right away, this is never going away. This is never going to go away. I think in almost every lecture that we talk about, especially moving forward, and definitely in React, we're going to be making copies of our arrays and our objects all of the time. So if you're feeling nervous about this, just, you know, be confident that there are going to be lots of examples of this in the future. Can I answer any questions about that?
So I guess just to better understand, when it comes to arrays and objects, they point to a reference. When it's numbers and strings, it's value that they're looking at.
When it's what?
When it's numbers and strings, it's looking at the value. But when it comes to arrays and objects, looking at the reference of the value.
Right, exactly. Exactly. Jason, I kind of want to go back to this question that you asked about, or this thing that you're saying about truthy and falsy. Can you elaborate a little bit more on what you're saying?
So, did you talk about the double equal versus triple equal before I got here?
Well, I haven't gotten there yet.
Okay, so
that's gonna get that, but I have that later.
So just real quick, like you guys are used to using the double equal as a comparison operator. So JavaScript's really weird. It has this extra triple equal, and it doesn't actually compare like literally. So like double equal, you got to compare a string to a string, or you got to compare a number to a number. The triple equal just compares what kind of, is it a string, is it an integer, is it a float, and it compares it to check the type. It's a type comparator. So you might have an integer and you might have a number, and they might look the same, but they're not really. But if you compare them with the triple equal operator, they might equal truthy, because they are similar enough that, like what he was talking about, coercion, where it coerces it to a different, like when you're trying to concat a string and a number, an integer, it coerces it to a string so that it can concat them and it becomes a string. So it's basically comparing, is this a string, is this an integer? The video I dropped, it talks a little bit more about it. I don't explain things very well, but essentially it's just comparing the state, like, is it this type, is it that type? And so the truthy and falsy is not literally equal to each other, it's equal to each other in type. So that's
right. So this example that I have in the console here, what Jason was saying and talking about coercion, right? And in the previous example, I said 5 plus 5 can equal 55 as a string. In coercion, the similar thing kind of works, right? Ruby or JavaScript is going to look at this and say, okay, I can make 5 a string maybe kind of easier than I can make 5 a number, because of, 5 as a, because if I write something like hello world, and I tell JavaScript to turn that into a number, it's going to be like, well, what the heck do I do, right? But 5 can easily be turned into a string. So the shallow equal operator does the coercion. It says, can I make one of these like the other? And if I do, are they true to some effect? But what Jason is saying is that when we do 5 triple equals 5, it's asking, are these wholeheartedly of the same data type, and without having to coerce them, are they equal? And here the answer is false, right? Jason, what I think you brought this up about, though, was when we were talking about whether something is undefined, if that equals false. And what I pointed out was that neither in the shallow equals, when we use the 2, that's shallow, and when we use triple, that's deep. And deep equals is the more stricter one. So from my understanding, if something doesn't pass in the shallow comparison, it's definitely not going to pass in the deep comparison.
It's been a few months since I messed with it. It was so February last time I messed with JavaScript, but yeah, JavaScript's got some real oddities.
It's got some really weird stuff.
Yeah, it's a fun language though. I really like it. So like, I don't know, I could go start going into it, but that's your job.
Yeah, I mean, I think that yeah, there are lots of weird things about JavaScript, and I, like you see, I'm constantly learning them, but there are a lot of crazy things, and I don't think anyone would argue about that. And it's important to remember that a lot of these weird idiosyncratic things don't need to be at the top of your memory all the time. Knowing all of these little things aren't going to prevent you from building an application. You might run into something and figure out, oh, this isn't working the way I expect it to, and then realize, oh, well, in JavaScript, this behaves this way, right? So all of these kind of weird details we're getting into you're not going to be facing them, upfront every day. You're going to be able to get a lot done without even thinking about them. Obviously, again, teaching myself a lot of things here, even though I've built several JavaScript applications before. So if these kind of small things are worrisome, as you're building, you'll take what you need and you'll get what you need, and you'll learn as you go. So there's no point in again trying to like memorize and be really hard on yourself and all these things. Obviously review this stuff, this is all stuff that's reviewable, and that's kind of why I've written this read me out or this JavaScript page up with a bunch of notes is that so that you can all come back and reference this. But yeah, lots of weird idiosyncratic stuff with JavaScript. But that was passed by reference, not by value. So we see here that when I was doing this, and just to kind of solidify this deep versus shallow equal situation, we, pass by reference will pass both the shallow and the deep equals, right? So if I have the new object and the same reference objects, which are two objects that points to the same place, right? They're going to pass the shallow equal and the deep equal, because they truly are not only the same data type, they are the same thing, right? 5 is going to shallow equal 5, but it's also going to deep equal 5 as a string, because they're the same data type and the same value. 4 and 4 are going to deep equal each other and shallow equal each other, right? But then when coercion takes place, 3 is going to shallow equal 3, but it's not going to deep equal 3.
This gets useful when you're like comparing like floats and ints, because
yeah,
you might not necessarily want to coerce a float to an integer.
Right.
Float is a floating point where it has decimals. So
right.
This gets useful if you don't want to make comparators. You can just.
Yep, exactly. Okay. Moving along, functions and methods. So at this point, I'm assuming that this lecture is probably going to go to 12:30. Just giving everybody a heads up. Hop off if you need to. The recording will be up later. Oh, and the recording from yesterday and the code is up, by the way. Let's talk about this difference between undefined as return value and undefined as an error. Let's see. I had this in my notes from previously. I don't know if I think that might have just come up. Maybe that was a note for myself to look up because I don't have the answer right away. So I'll move this to the bottom as well. Okay. Functions and methods. Let's talk about defining a function. Ruby was pretty simple. We have def, method, argument, and stuff goes here. Right. Not so in JavaScript. Whenever we want to write a function in JavaScript, we write the word function. Okay. And then if we want to give this function a variable value name, we name it my function. Okay. And then we put these parentheses here, arguments go here, right? And then we use these curly braces or brackets, right? And we open up the function, right? The function needs to go in the entirety of this function needs to go within these brackets, okay? And this is how we define a function in JavaScript. And then we can say, maybe we'll say this is a number, we'll say number and to multiply, we'll say number times num to multiply, okay? The most important thing about JavaScript functions, at least in the way that we're writing them here, I call these regular functions, and they're different from arrow functions, and we'll talk about them in a second. Oh, no, shoot. These are regular JavaScript functions. Is that there are no implicit returns in regular JS functions. You have to write return. And this is going to be, I think, the most tricky thing for people to catch on to at first when we're learning JavaScript. Just reminding yourself that if there are other parts of your code that require the return value of a function, and you're asking yourself, why am I getting undefined? Why am I getting undefined? There's no return value here. It's probably because you didn't explicitly write return. Okay. It is also possible to write what we call an anonymous function, where we don't assign this function to a variable, but we generally use that when we're doing, iterations, or what would be considered the block. And I'll talk about that a little bit more in a second. Let's see. I think I have an anonymous function down here. Yeah, so we'll get to that in a second. Okay, so now I can say my function, and then I can pass in 5, and I want to multiply it by 2. And the return value we should see in the console is, oh, didn't work. Let's see. I guess we'll have to console.log it. It's also important to remember that console log doesn't return anything. So if we want something to show up in the console, what I would have to maybe do here is also return this. And just like in Ruby, once you write the return, nothing underneath that return runs, right? So if I put this console.log underneath the return, the console log will not appear in the console. As we've just seen, return values also do not appear in the console. So return values of functions do not appear in the console. If you want to see something like the return value, you might have to do something like this. And again, you can't say return console log, because console logs do not have return values. Even though the console log is running, if my code requires the return value of this function to do another operation, right, the return value is going to be undefined.
Console log is great for like bug type situations where you want to see what the value of something is at a certain point. Drop a console log in there.
Arrow functions. I just want to show you how to do these, but I cannot stress enough how much I want you all to focus on. And sorry, my AirPods have died, or at least the right one has.
Chris, did that show up in the console?
No? Oh, hold on. Come on. Osha, can you ask that question again?
I was just wondering if that showed up in the console, the function.
Right, the return value did. And
okay.
Console logs will always tell you which line the console log was written on, which is very helpful. So on line 101, we wrote a console log and it was there. But remember, we can't see the return value. So maybe what it would be more helpful to do is if I console logged this, and we can see that this function is going to return 10, and then console log is going to return the return value of that function. There we go. That's more helpful.
Okay.
I also had a quick question.
Yep, go for it.
Which was, if you type return on the line that follows, say like num times num to mult, would that return maintain the value of the last line, or do you actually have to have it followed by?
What do you mean?
Sorry, not clear. So if you just have return as a standalone on its own line, would that have an implicit value of whatever was last returned in the function, or?
You mean like if I did this?
Yeah.
This would not work.
Okay.
Yeah.
I see. Cool.
Okay.
JavaScript is super literal, so it needs to be told exactly what you're passing and where you're passing it to at all times.
Yeah. So with arrow functions are inherently anonymous in that they are generally written like this. So the syntax is quite different here, right? If I were to change this to a normal function, it would just be something like that, right? So it looks different, but the reality is that we just take out the arrow and then add in the word function, right?
but these are called arrow functions. So this is a normal function, an anonymous function, right? And this is an arrow function. And arrow functions are inherently anonymous, meaning that you do not define the variable that we would tie the function to. We always have to store it to a variable value. So my second func would be here, right? Or I prefer setting my arrow functions to constants, right? Because I'm likely not going to change them. And so here would be the same. Here would be the same thing. There are a couple extremely important things about arrow functions. Again, we'll talk about them later. I don't want you to think about them too much right now. Please, 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 for the time being, write all of your functions this way. Once we get to React, students have a terrible habit of writing all of their functions like this. And by the end of the React section, they don't even remember how to write functions this way. So I'm really, really, really just going to drill it into you as much as possible. Be very comfortable writing this way of functions first, and then over time, migrating over to this way of writing functions. It's inevitable that you'll get here. And again, like I said, you'll generally see a combination of the two in the curriculum, but you know, please get this down, okay? A couple other things about arrow functions. One-line functions have implicit returns, and you don't need curly braces to have implicit returns. So if I were to take this function and I were to write it on one line, I could just do this. And this has an implied return value, and it doesn't need curly braces. Okay. But again, one-line arrow functions, don't worry about writing your code this way. It's all right. Practice doing it this way. We already saw how to pass in an argument, passing in the arguments here. Here are some definitions that I think it's extremely, extremely, extremely important for people to understand. What is the difference between a function definition or declaration? We kind of use them interchangeably. The reference to the function and the execution of the function, okay? Up here, we've seen that we have a function declaration. Okay. Unlike Ruby, JavaScript makes their functions what we call first-class citizens. And I don't exactly know why they're called that, but JavaScript is also homophobic, so I don't know. What that means is that JavaScript functions are objects, okay? Meaning that they can be kind of passed around, right? So this is a reference to that function. Maybe I'll call it example function. Here's a reference to that function, right? I can pass this reference to this function as an argument to another function. I can say function call another function, and that function comes in as an argument, and then I execute it. So basically, this function's whole purpose is receiving a function as an argument and then calling it. So I've passed the reference to my first function as an argument to my second function. This is not something we were able to do in Ruby, right? I just saw that Matt's dog is here, and it looks so cute. Oh my God. Sorry, everyone should direct their attention to Matt's dog for like 2 seconds. I'm gonna actually just spotlight it for a second. So cute.
This is
Okay. Okay, back to
That's my
my
jam right there.
okay.
back to JavaScript. Okay. We'll have time at the end as a header. Okay, so here is a definition of a function, right? Here are two function definitions. Here I have the reference to a function, and I'm passing in that reference to a function as an argument to the other function that I declared, right? The execution of the function is when we actually wrap these double brackets around it. So I guess here are two function definitions, two function references, and a function execution, right? Where one function is executed. In order to execute it, right, it is expecting the reference of another function. Okay. Are there any questions about these three kind of phases of functions? I've been trying to think about a good kind of metaphor for this, and sometimes it feels like water, like, or, you know, water can be a liquid, a vapor, and a solid, kind of. You know, functions have kind of three phases to them, right? First, we define them, we can then reference them, and then they can actually be executed.
So so you're declaring what it is in the first one? Obviously, it's a declaration. Yep. The second one for the references, you're just like, you're referring to them, or like, is anything happening in the actual console?
No, because they're like variables, right? So let's console log these. And you can put many things in console log, by the way, which is very cool. So if I console log these, we see here that when I console log them, they're just saying, hey, these are functions. And we get a glimpse at how they're defined, right? But they're not being executed yet. This is extremely important because, as we'll see in tomorrow's lecture, JavaScript runs on events. As we saw yesterday, well, kind of, we didn't quite get there, but JavaScript expects, that's why all of that stuff about books was in there, because that's for tomorrow's lecture. People are going to click on things, right? People are going to scroll, type things in, right? In JavaScript, we want events to happen when the user is interacting with our application, right? What that requires us to do, right, or the logical thing to make sense would be like, hey, when this happens, do this, right? So tomorrow what we're going to be doing is we're basically going to be saying, defining a bunch of event listeners. We're going to put a button on the screen and we're going to say, hey, when someone clicks this button, do this thing, run this function, do this event, change the color of the background, right? Add these divs to the screen. And when we do that, we're going to want to define our functions, right? And then we're going to want to tell JavaScript, hey, when this happens, do this. And in that moment, we're going to pass the reference of the function so that the browser knows what to do when that event happens, right? So we need the event to be in this package, in this variable package where it's kind of in a resting state, right? Waiting to be executed, right? So that's what the reference of the function is for. We've defined it. You know, it's like the difference between it's like baking a cake, right? First you bake it, right? We're defining the function, we're baking it, and then there's the instance of the cake, right? You can pass it around, you can take it to your friend's house, and then at your friend's house they can finally eat it or execute it, right? So it's the same thing with JavaScript. We're defining an event, we're taking the event to an object on the DOM and saying, hey, when someone clicks you, eat this cake or run this event, right? And that's not something that we ever had to do in Ruby, right? In Ruby, it was just like, hey, you know, functional programming, do this, do this, do this. I guess this is also functional programming in JavaScript too, but the purpose of what Ruby's goal was different than JavaScript's role. So that's why it's important that functions are first-class citizens, or that they can be passed as references through their variables to other pieces of code. Does that make sense? Does that answer your question, Risha?
Yeah, totally.
Okay. All right, so here, defining the function, baking the cake, referencing the function, seeing the instance of it, being able to pass it around, right? Take it to your friend's house, and then the execution of the cake or the eating the cake. We're saying it's happening, right? The event is running now. Okay, Are there any other questions about this? Yep, that's true, Franklin, except not the US anymore because of COVID. All right, so functions are first-class citizens, meaning that they can be saved to variables, and in an array as objects, they can be passed as arguments or set as return values. So that's the other thing. We can have array of functions, right? This is not something that we were able to do with Ruby. I have an array of functions, right? I can also have object of functions.
When a function is built inside of an object, it's called a method.
When a function is built inside of an object, it's called a method?
Yeah.
You mean because we can say object of functions dot first and execute it, and that's a method now?
Correct.
Exactly.
And then you can access the method with the dot notation.
Right, so when you call something on something, it's a method, and that's different from how it would have been in Ruby, right? We're defining of functions, but as Jason said, these become methods once they're called on an object like this.
Which becomes really cool when you're doing like object-oriented programming. You can create one object that's solely for the manipulation of a specific model or event or something, and then another object which just handles the data, and you have everything like single source of truth in that way.
Right.
So did you just say that a function becomes a method when it's called on another function?
It's not that it transforms itself into a method, it's just that
It's like where it lives is when it changes its name.
So
like
like
when you build it outside of object and standalone as a function, but when you build it as a subset of an object, like inside of an object, it's called a method.
I wouldn't argue that you build it as a subset. I would argue that you place it, right? Because I honestly don't. I mean, I guess you could define a function here if you wanted. I don't know if that works. Does that work?
I think isn't it the key that's the function name and values
Yeah, it does work.
Or did it work?
So you can, I would never recommend doing this, but you can define functions right inside of an object.
Can you elaborate on what an object is?
An object is just like a hash in JavaScript.
Okay.
Oh, maybe you can't. Can you? Did I not do that right? Function console log on my function. That doesn't seem to have worked. Let's see though. Oh, it does work. Okay. Right. So objects are what we would have called hashes in JavaScript. And I learned something new. Again, I would never do this. This is very cluttery, right? But you can apparently define a function inside of an object. But the thing that Jason was trying to say was that we would say that we're calling the first method on the object, but the method is just, you know, I wouldn't be mad if you said that it was a function as well.
So I just dropped some code in the chat. It doesn't have like a code block in the chat, so it looks, but so I have an object here, and the object is the to-do list, and then the methods are the pieces of the object are, each one represents a function that does something to that specific object, but it's just called a method because it's built within. But each function or method, when it's inside of the object, is built as a like a key value pair. So it's still like a hash format.
So like on line 142, let object of functions equal. Inside of that, there's curly brackets. Instead of doing like key values, couldn't you just do example function comma, call another function? Or does that not work?
Example function, call another function like this. This is an array.
Yeah, right. So you're not able to. Okay, so an object.
An object
be
is
an
made
array,
up of key value
an array.
pairs. No, an object is made up of key value pairs, just like hashes, right?
Oh,
Objects
okay.
are always made up of key value pairs. Right? Arrays are not. They have indices to determine their location.
Gotcha. So, but in this case, object of functions and array of functions, they perform the same.
Object of functions is an object with keys that have values of functions. In one case, we're defining the function. In the second case, we're referencing a function. Right?
Okay.
This is a function definition. This is a function reference.
Gotcha.
So this is a function definition. This is a function reference. In this case, we are doing two function references, but as we've seen, we could probably do a function reference and a definition. We're defining it and we're referencing it, right?
Would you be able to nest it like we did with in Ruby nest hashes? So like
Yeah, of course.
inside of the object function?
Yeah. These can be made up of whatever we want, right? We can also maybe put a number here. Objects are just like hashes in Ruby. They can be made up of a bunch of things. Same thing here. In this array, we can also put a string and a number.
That's the funny thing about programming languages is that they all call the same thing something different. It's a hash, it's an object, it's a, you know, like in Python they call it something else.
Mm-hmm. Yeah, it's funny. Okay, another thing to talk about is references of functions and anonymous functions and kind of when we use them. So I said that we don't have to define, we don't have to give the name to a function. We could just kind of write it like this. However, this is basically pointless because once we've defined it, we can never use it again, right? We can never reference it again because we've never stored it anywhere. So we use anonymous functions for exactly that purpose, for when we're in situations where we would write a function that we would never use in another case. In this example, it would be for like iteration. So let's do this really quickly. I'm just going to have a number array equal 1, 2, 3. And then we're going to define a function that, and then we're going to, we'll define a function that multiplies every number by 2. So mult by 2, right? We'll take in an array, or sorry, we'll take in a number, an individual number, and then we'll say return that number multiplied by 2. Okay. So if we were writing something like this in Ruby, we might say something like num array dot each do, or each, and then say, you know, the number is here, and then we say number times 2, right? That's how we would maybe have done it in Ruby. But in JavaScript, this block that goes here is usually just a reference to another function. So this exact method, or how it would be written in JavaScript, would be something like this. It would be something like num array dot for each, which is the new version of, or which is how JavaScript iterates over arrays. We would then define an anonymous function in here, right? We could say, you know, this kind of behaves as the block, right? And then inside of the block, we say what we want each thing to do, num times 2, right? So I can define the anonymous function here, or I can reference the function that I previously wrote, like multiply 2. So what I'm saying here is like, hey, I want to take each of these elements in the array and pass them each to this function that I've already defined, you know, that, and that's going to do what I want it to do, right? So we have two options here. We can either pass in a reference to another function, or we can define an anonymous function. I personally think that this way is much cleaner, but this function is so small that, you know, it's fine, and you will definitely see people do. Oh, I have this down here. You will definitely see people write their functions in line. Okay, so there are a bunch of.
Can you write the function in line? Can you write the function in line real quickly, just again? I'm just trying to take note of it.
Oh yeah, I have it right here. Right, this function is the same thing as this function.
Right.
So I can write this anonymous function right here as the argument, right? Or I can pass in the reference to the function that already does that here, right?
Mm-hmm.
Would you need to put in the bracket num after mult by 2?
No, because think about it this way.
It just assumes.
We want to pass the reference to the iterator, because if we do this, when the code executes, it executes this function, and then the return value gets passed to for each. So this is why passing in reference is important, right? We want for each to determine when something gets executed, because whenever we write the parentheses, the function executes in that moment, right? So this.
I think David was asking, or at least I'm now asking, if he wasn't, if when you do it the kind of a more elongated way, after explicitly saying function, do you need to put do you need num in between those parentheses?
Well, yeah, because you're defining a function. It's an anonymous function, but you still need the place to put the argument. Every function needs the parentheses.
I mean the num inside the parentheses. That's what I'm.
Yeah, that's the argument, right?
If you don't put
okay.
Because each individual number in the array, or each element in the array, is going to become this, right? It's just like this in
Gotcha.
Ruby, right? This is the placeholder. We can imagine the placeholder. Kind of, it's different. Obviously, this is an argument to a function now.
Mm-hmm.
But we can imagine that maybe in Ruby, the block was just another method that we were defining that took in an argument and then did this to it, right? That's kind of what I'm asking you to imagine. So again, either way, works. Okay. And then some iterators to go over. So map is an iterator that we use when we want to make a transformation on every element in an array. The new array will always have the same amount of elements as the original, right? So if we took this method up here should actually be a map, right? Because then the return value here is going to be a new array with 2, 4, and 6, right? For each, it's important to remember, has no implicit return value, just like each in Ruby. Or it always returns the original collection. Okay. So map is going to return a new array. For each is how we overuse arrays. For each we cannot use for each with objects. I guess I'll move this note down here. If we want to iterate over objects, we use it's a for loop, a for in loop, and I don't think we'll have time to go over this today. It's not very often that I think in some of the labs they're going to ask you to do looping over objects. So and if you're struggling with that, you can come to Open Office Hours and we can talk about that. But unlike in Ruby, where you could iterate over hashes, in JavaScript you cannot iterate over objects. Reduce, select, and find are all going to behave the same way, right? So maybe we want to take this number array and we just want to select, or I'll use find, because find and select kind of work the same way. I just want to find the first a number that is greater than 2, right? So I'll say numarray.find, and then we can again just define the function in here, and then we can return if the number is greater than 2. And it works just like Ruby, right? This is going to return a true or false, a Boolean value, right? And once true is the return value, then the iteration stops and that instance is returned, right? If we did this, this is going to return, an array of numbers that are greater than 1, right? So the return value here should be an array of 2 and 3. The return value here should just be 3, the number.
You meant selected on 187, right?
Yeah, select. So again, go ahead.
Yesterday we had to, I was doing one of the labs where we had to do something. Can you not do something like num is greater than one number and less than another number at the same time? Because it wasn't working in the lab that I was doing, so I had to do it like a really weird way.
Did you do it like this?
No, I didn't do it like that.
So
I did like
num is greater than 1 and also less than 10.
Okay, so you have to do and, you can't do just like 1 greater than, num greater than like another sign symbol, and then like 5 to find num,
Like this.
And like,
I guess what he means to say is that you can put a statement that the value is between two numbers.
I just wrote it in the chat. So like, does that not work?
I don't think so. If I did
You just wrote it.
1 is greater than 3, but less than 5. No, that works.
Like, for some reason, it wasn't working in the lab that I was doing yesterday. I did the one where you had to do the good morning, good day, good evening for the time. And it was being weird.
You might try doing something like this. Doing the ands. If the other way is not working. But that should work. We just tested it out in the console. Obviously, the console has proved to be tricky before, but I think that should work. I had never done that before. Cool. So again, remember, if we were thinking about this in Ruby, we would say numarray.select, and then we would have a number, and then we would say, num is greater than 1. So the syntax is, the thought process is similar. It's just kind of we're imagining as if these blocks were their own functions themselves, right? And again, I can abstract this away, and I can call this function greater than 1, and I can say greater than 1 here. Passing in the reference, not executing it. Remember, we baked the cake, we're saying, hey, select, you determine when the cake gets eaten, right? You figure this out. Select will execute this method on its own. It will pass in each element from the array into this function that we defined, right? So again, either way works. And personally, like I've said before, I think this way looks a lot cleaner. Define the function, pass in the reference. But this is such a short, quick, easy thing to write. Sometimes it's not even worth giving the function a variable name, right? That's kind of the point here. All right. Any questions? Okay, if you haven't had enough, we've got one more tricky concept for you guys. Scopes, closures, and hoisting. Okay. So There are two different types of scopes. We have block scope and we have lexical scope, right? Lexical scopes create closures. And kind of what I basically mean by this is if I define a function, this function has its own scope, okay? So if I define a function here, right, I can't access x outside of this function, right? I define that function in there, or sorry, I define that variable in there. It's inside of that scope, right? And when we're saying that something has its own scope, that's what we mean. That's what essentially a closure references, right? This function has its own scope, which has created a closure, which presents this variable for being accessible outside of it. Okay, if I define a function within this function, this function has access to the variables in the scope outside of it. So this function has access to the x variable value and the a variable value. We should get like an undefined, or not even an undefined, but just that, you know, I'm forgetting what the error would be. Like, what would the error be? Like something does not exist, right? So we can say that like out here is like the first layer, right? Right, the highest level scope. And then when we define this test function, it creates its own scope, and the variables inside of there are not available to the scope outside of it, right? But if we define a function inside of it, this function inherits its previous scopes. So it has access to x and a. This was not something that Ruby did, right? If we needed something from here to get inside of a Ruby function, we had to pass it in as an argument. We don't have to do that in JavaScript. JavaScript inherits the variables from the scopes, you know, that it has access to. If I define yet another function, these are sibling functions in that they're in the same scope, but they don't share the same scope. They have their own individual scopes, right? So I do not have access to y here, right? Y is written in this, not here, right? And if I define another one, I obviously don't have access to it in here. Okay, does that make sense? So we're talking about scopes here, right? They're each creating their own scope. And when we write a function and define methods and variables inside of it, we've created a closure, right? The logic of
function
scopes
yet another has access to variable x, correct?
Exactly. Yes. This works. Both of these functions have access to x, right? But this function does not have access to any of the variables defined inside of its children functions. Okay. Scopes create these closures.
That's known as inheritance.
Hold on.
I wouldn't call that inheritance. Yeah, you could say that it inherits the variables from its.
But it's not inheritance that will.
It's not really inheriting, because that's kind of a reserved for object-oriented programming, right? We would say that, yeah, the variables in the scope that it was created in, it has access to all of that, right? It's called the scope. It's, well, I don't know, lexical scope. I don't know exactly what I would call this. Function availability through scope. Method availability, or variable availability through scope. Okay.
Or even just scope inheritance, as long as you put that preface there.
Yeah, I guess you could say scope inheritance, sure. Okay, that's basically scopes and closures. One important thing to kind of remember, though, is that I can call my sibling function from within this other function, because they are technically, right, this function was defined in the same scope as this function. So this function technically has access to this one. Okay, kind of crazy. And we'll talk about why coming up next. So let's talk about how JavaScript compiles things. Okay. There are two phases when JavaScript runs a file. The first phase is the compilation phase. This is the first run through of your code, okay? The first passes the compilation phase, in which the engine steps through our code line by line. It ignores all function executions, right? So if we're looking at this here, we'll start at the top, right? It reads this line of code. It says, hey, we're defining a variable here. It reads this line here. It says, okay, cool. You know, we're defining a function. Sorry, let me get through this list, and then we'll talk about the execution phase. Okay, so it ignores all function executions. When it reaches a variable declaration, the engine allocates memory and sets up a reference to the variable's identifier. However, it does not assign the variable value. With var, the variable name is declared, but the value is not set until the execution phase. With let and const, the names are reserved, but the values aren't set, nor does the program allow the variables to be called until they've been assigned variables. We're going to touch on this a lot in a second. This is essential to this concept called hoisting. See hoisting below. And then when the engine encounters a function declaration, it does three things. First, it allocates memory and sets up a reference to the function's identifier, meaning the variable or the variable we gave it, if there is one. It creates a new execution context with a new scope, right? Meaning that the closure is being created, right? And it adds the reference to the parent scope, the outer environment, to the scope chain, making variables and functions declared in the outer environment available in the new function scope. So I guess you would say that it has access to the variables through the scope chain versus inheritance, maybe, Ryan, is what I would say. And then in the execution phase, the JavaScript runs through each line of code again and then executes the functions when necessary. Okay, so if we're going to look at this in this way, here's what's happening. Okay, we would say what JavaScript is saying is it's looking here and it's saying, okay, we recognize that someone is using let to define a variable. Right, so we are going to reserve this space in memory, but we're not going to let a user reference it, right, until it's been defined. Okay, and then it says, okay, so there's a function being defined here. Let's create a scope for this function that's separate from this kind of global scope out here, right? And same thing, we're defining a variable, we're defining another function, right? We're going to ignore this execution. And then we're defining another variable, giving it its own lexical scope again, right? Here's another variable, and we're going to ignore this function execution. We're also going to ignore this function execution. And then it starts from the top again, and now we're in the execution phase. So it says, okay, let's assign this variable, a equals first var, We've already defined this function, but I'm reading through, okay. But yet another is called, so we can execute this here because it's already been defined in the first phase, the first pass through, right? And then in this function, things are being run through here. Well, I guess what would need to happen is that these would have to be called as well, because we would kind of be ignoring these function definitions, and then these would get called here. And because yet another and another function were both defined in the first walkthrough phase, right? These functions can be called. The kind of tricky thing with var, and this is kind of the last time that I'll talk about it because it's really crazy to talk about, is this concept called hoisting. So hoisting isn't anything physical that happens in our code. It's more of like a metaphor for what this kind of thing feels like, right? So another way to think about this is to say something like, or maybe I'll keep this here in case people want to reference this, and I'll just start a new bit up here, right? If this were the top of our JavaScript file, and I said my function and I executed it, but then I also wrote my function here, and I defined it below. Because JavaScript ignores the function executions on the first walkthrough, right? The compilation phase. When the code actually runs, it's as if the method was defined above, right? Because when we think about the order of operations, how things are executed, the function definition happens before the execution, right? So it's called hoisting because it feels like all of the function definitions get moved to the top of the page, right? It's kind of best practice to always define things above where you call them, even though this thing called hoisting happens. But another kind of thing to talk about is, again, the last kind of time we'll talk about var, is that if I define, let's see, I always struggle with coming up with examples for this. If I define var here, or if I say var name is Chris, and I put and then I say also my name is, I'll use backticks here. What happens is, as the code is running, it first in the compilation phase ignores the first function declaration, right? It then sees the function definition. Okay, hold on. Oh, I might be confusing myself here. Oh, but it ignores this. It ignores this. This is basically a method call, right? So it ignores this. It waits until the execution phase. And then it moves on to the variable name declaration. However, in the compilation phase, only the variable name itself gets declared, but the value does not get set. Compilation phase. So basically, it's as if we've just written var name, okay? And it does not become assigned until in the execution phase, the equal sign is established. So if I were to run this, what would happen would be my function would run, the console log would run, and it would say also my name is undefined, right? But then when we get here, the variable is assigned, and then console log name comes out. So let's see if I can actually get this to work so you guys can see what I'm talking about. Also, my name is blank, and then the console log name happens here. So what happens is with var, and this is another reason why it's extremely confusing and we don't do it, is because JavaScript does not, JavaScript just basically preserves the variable name, right? This could have been whatever, but the name of the variable, that kind of gets hoisted, right? Just like with the functions, if I define a function, space in memory is allocated for that function. Same thing happens with var, right? However, the value isn't assigned until the execution phase, right? So that's why in the execution phase, my name came up as blank, because it's not until the line below that the variable is set, and that's why this console log runs, and the name is declared at this point. Extremely tricky, I know. If we were to use let, the difference is now that, and I'm probably going to get an error here. Oh yeah, I see the error in the console already. With let and const in the compilation phase, the same thing kind of happens, but JavaScript refuses to let you use variables declared with let and const until the value has been assigned or it's been initialized, which happens in the execution phase. So now we can see that on line 213, we're getting an error that says cannot access name before initialization. So it's always good to define your variables above to prevent this confusion with, and what did I do now? Let name is Chris. Oh, it should go at the very tip top. Nope, it's still not working. 214. Let's see, let name equals Chris, my function. Wait, why isn't that working now? Let's see, function, my function, console log, my function. Oh dear, let's see. What am I not understanding? JS214.
You don't have to save the index.js.
Oh, did I not save it? Oh, I didn't save it.
Oh.
Sorry, my bar was there. No, it still isn't working. Line 212. Let's see. Is it? No, this doesn't change anything.
Chris, is it something with the backtick in the parentheses? Apostrophes.
Oh, I see. No. That shouldn't matter. Wow, okay. Let's see. So at the moment that this is defined, this variable name hasn't been set yet. Does it need to go in here? That works. Hold on a second. I'm confusing myself now. Oh, name has already been declared. Okay. Let me, I might have used name somewhere else. This is my fault for letting this get specific. Nope. Okay. Oh, I see. Okay. One second. I'm so sorry, y'all. This has gone on for way too long. I'm going to use a different console. see if I can get this to work. Why does it work there? Okay,
Because
I think
when
it.
you just use let globally, it doesn't create a property on the global object.
What does that
when you
mean?
so when you create the global variable at the global level with var, it actually like creates the object and assigns the variable, but it remains undefined with let. So let has to be within block scope, within the scope of some sort of function. You can't use let outside of a function and pass it, because it's not, it won't assign the variable. I used to be much better at speaking. Sorry, guys.
It won't assign the variable. But okay, this might be something that
docs have something about it.
Yeah, this might be something that I have to look up more, because I thought this would work, and it did work in here, but I'm not understanding exactly why it's not working in this.
Could it be because the name is in a string instead of backticks? Would that have anything to do with that? Or?
No. They're all backticks. Hold on a second. So I'm just going to do test.js, paste this in here, save that, make this test. Come back over here, refresh this page. Yeah, so now it's working. I don't know why it wasn't working before.
Because in the console you don't have an object, like a global, like a window object in the console. When you're running the code as like a Java.
But I'm running the code here. This is the code running.
Weird.
I didn't run anything in the console. So, right. So just to recap. Okay. If I set this equal to var right here, we're gonna get, this is gonna be blank, right? Sorry, if I let me set up this order back correctly. So although I'm calling my function above from where I defined it, right? Because this gets declared first, right? Function executions are ignored until the execution phase. This still works because, again, JavaScript runs through our code twice. The first time the functions are defined, and the second time they're actually executed where they're said to be executed. If we're using var, let var, if we're using var here to define the variable with the name of name, var is hoisted in that the variable name is saved in memory. So in this case, name is saved, but it's not defined yet. It's not assigned a value until the execution phase, right? So that's why in the execution phase, when this function runs from top to bottom, this value hasn't been assigned yet. So this is going to be blank as a string. And then down here, the variable is going to execute. And I realize what's happening now. It's that my browser is caching my JavaScript file, so it's not updating. So I need to be using incognito mode to prevent the JavaScript file from caching, which is exactly what we see here. My name is blank, right? But then Chris is console logged. And if anybody else said Slim Shady in their head, I'm like so disappointed at our culture. Okay, so that's that. However, if I use let, we're gonna get an error here because
var and let.
Oh, sorry. I did that again. We're gonna get an error here because with let and const, although JavaScript technically does the same thing, it technically hoists the variable name and preserves the space in memory, it doesn't allow it to behave like var. So we're going to get an error here, right? So now our error is going to say cannot access name before it's initialized, meaning we can't access it before, I guess you wouldn't say the variable value is assigned, right? Because let will allow us to leave the variable name here, right? Or not assign it at all. Right. Oh, I guess it does. Okay. Before initialization. Is this just another error from? So if I move this up here, oh, it needs to go above. I keep forgetting it needs to go at the very tippy top. For the function.
Does it just have to be before the function is called, or does it also have to be before the function is defined?
Before the function is called, right? Because we could define this function up here, and this is still going to work. The reason why it's undefined right now is because I didn't ever give it a name. Those tricky caches. So all this is to say is that things get really confusing if you use var, because var essentially kind of on the compilation phase, JavaScript will reserve the var variable, right? But the value isn't actually assigned until in the execution phase, 2 and 2 are put together, right? Let and const prevent this kind of confusion, and I know that it all seems like a big confusion right now, but it prevents this confusion by saying we're not even going to let any variables be accessible until the execution phase, so that order is kind of enforced, right? So the best thing to always do, this is the key takeaway of all of this, you are going to be asked about hoisting in your project reviews though. So if this is something that we need more exercise doing, let's talk about it in our meetings or during office hours. Always define your variables and your functions on top if possible. Basically, follow your intuition. When you're writing code, you're always going to want to say, here are all of my variables, and then write your code underneath. And that's going to prevent most of this confusion from even happening, right? Hoisting is not something I think about on a day-to-day basis when I'm coding in JavaScript, but it is important to know that there are 2 phases that JavaScript runs your code through, right? Before it actually executes, or, you know, there are 2 phases. One is compiling and the second is execution. And I think that that's everything that I wanted to go through. This ended up being a 2-hour lecture, even though that was what I was avoiding, but I really don't know how they expect me to talk about all of this in 3 lectures. So thanks for everyone for bearing with me. I know this was a lot. But to be honest, I'm throwing all of this information at you today. I think that this is the most complicated lecture because there's just so much. And I truly believe that moving forward, all of these concepts will start to make sense, but I need to get them all out on the table before we move forward, okay? So take it from me, this is the most technical, complicated lecture of the entire JavaScript section, just introducing all of the idiosyncrasies, but moving forward, it's just practicing them. Okay? I'll have the recording and the code up ASAP. And again, you know, if you took any notes or have any questions, unfortunately, I ate into our open office hours time. And speaking of eating, I need to go eat lunch now. So, you know, there's no open office hours today. There will be 2 tomorrow, one right after the lecture, and then another one in the afternoon, like always. But before you all go, the last thing that I want to say is that Gretchen and I are having a happy hour tonight instead of Friday because I am traveling on Friday afternoon, and also Gretchen no longer wants to work on Fridays. So our after project week happy hours are now going to be on Wednesdays. So come hang out. I think that it's going to be at I think it's going to be at 6:30 Eastern time. I'll double check. Yeah, I mean, preferably it won't be code related, but if you sneak a JavaScript question or 2 in during happy hour, I won't be mad. I hope you all have a really great day. Hope to see you there. I think it would be really fun. We have some new students that I don't think people have gotten to meet yet. And of course, I think that Matt will definitely be showing off his dog, hopefully. So come hang out with Matt's dog virtually.
He's going to learn JavaScript too.
That sounds awesome. I'll talk to you guys later.
Later, y'all.
Bye.